Hello and welcome to our little mini lesson on how to find a reference angle. This is for our trig class. So what you need to know is that this angle here is 0 degrees or 0 radians. And as you go counterclockwise, each axis that you hit is an increment of 90. So this would be 90 degrees, which is equivalent to pi over 2 radians. And then another axis would be 180 degrees or pi radians. Another axis that would be 270 degrees or 3 pi over 2 radians. And then a full circle would be 360 degrees or 2 pi radians. Now, when we're finding a reference angle, in the first quadrant, the angle is its own reference angle. So if you have an angle given between 0 and 90, that angle is going to be its own reference angle. But any angle bigger than 90, you're going to have to find the angle that connects with the x-axis. That would be an acute angle. So there's two criteria for a reference angle. Okay, criteria number one, a reference angle needs to be acute and it has to be positive. Those are the two criteria for a reference angle, and both of these quantify that it has to have a side on the x-axis. Again, I'm saying x-axis. It has to have a side on this axis here. So one of the things that gets a little complicated for some students mainly are the radian angles when you're finding a reference angle. For the radian angles, just remember that this value over here is pi, and if you make more than one revolution, it's going to be an odd multiple of pi. So the angles that are coterminal to pi could be 3 pi, 5 pi, 7 pi, so on and so forth. Angles that are coterminal to 2 pi are going to be even multiples of pi. So 2 pi, 4 pi, 6 pi, 8 pi, so on and so forth. Those are the two main things you need to remember when you're doing reference angles in radians. So let's look at some examples. Okay, let's start with 290. And I'm just making these up to show you how the reference angle works. Okay, so the first thing you want to do when you're given an angle and you're asked to find a reference angle, you want to figure out in which quadrant your angle lies. So notice 290 is a little bit bigger than 270. 290 would be in quadrant 4. It's a little bit past 270. Now, the reference angle is always going to be the angle that fills the gap between the terminal side of the angle and the x-axis. This is going to be your reference angle. Notice that that angle is going to be acute. It also has to be positive. So the way that I figure this out is I ask myself, I'm going to say, hey, how much would it take to go from 290 to 360? Or mathematically, you could say 360 minus 290. So the reference angle for 290 is going to be 70. Because if you add 70 to 290, you get 360. 70 degrees is the amount that it takes to get from 290 to 360. Now let's do an example in radians. Let's say we're given an angle of 5 pi over 4, and we want to find the reference angle. So what we know is we know that 5 pi over 4 is bigger than 4 pi over 4, and 4 pi over 4 is pi. So that's going to be this guy right here. And since 5 pi over 4 is bigger, then we know that that angle is going to be in quadrant 3. So here's 5 pi over 4 in quadrant 3. And again, remember the reference angle is going to be the angle that's made up of the terminal side of your angle and the x-axis. So this is our reference angle. And so here I'm going to ask myself, how much would it take to go from pi to 5 pi over 4? What angle would that need to be in there? Well, remember pi is the same as 4 pi over 4. I want to get to 5 pi over 4. So that's an increment of pi over 4. Now, mathematically, if you want like a formula or something to do that, what you're going to do is you're going to say, okay, if my angle is 5 pi over 4, I want to subtract pi from that, and that will give me pi over 4, which is my reference angle. Now remember, you need to check and make sure that this meets the criteria for a reference angle. First of all, pi over 4 is acute. It is less than 90, because 90, remember, is pi over 2, and a fourth is less than a half, and it is positive. Let's say we want to find the reference angle for 1072, and you don't want to really figure out what quadrant that's in. That's a huge angle, and we need the reference angle for that. What you want to do is you want to subtract 180 degrees over and over and over again until your angle is less than 90. And then if it's negative, make it positive. So let's go through how that would work. So we're going to minus 180, and to do that, I'm going to use my handy dandy calculator. So 1072 minus 180 is 892. That is not acute, so I'm going to do it again. And I'm just going to keep minusing 180 until I get an acute angle. And you can see that this process is a little involved. And it's taking so long because I'm writing these steps down. If it were me just doing it on my calculator, I would do minus 180, minus 180, minus 180. And then here, notice I get an angle that's less than 90, but it's negative. So I'm just going to make it positive. And so 8 degrees would be my reference angle. Now I can prove that by going to the coordinate system, and I'm going to go full circles, okay? So remember, a full circle is 360, right? So there's 360. Another 360 would be 720. Another 360 would be 1080. And notice at this point, I've exceeded my angle. So I know that this angle here, 1080, is coterminal with 360. This is 1080 degrees, or 1080 degrees. And our angle is 1072. So that's going to come up a little bit short of 1080. The question is, how much would it take to go from 1072 to 1080? Well, that's 8 degrees. And so that shows that this technique of subtracting 180 repeatedly until you get an angle less than 90, if it's negative, make it positive, that technique will always work for finding a reference angle if you're in degrees. Now, let's do another angle, but this time we're going to do a crazy radian angle. What if we had 31 pi over 15 and we want to find the reference angle? Well, the technique that I just demonstrated about subtracting 180 repeatedly is going to work here, But you have to understand that 180 is equivalent to pi radians. So this time I'm going to minus pi repeatedly until I get an angle that is less than pi over 2. So let's try this. And again, the Casio makes this super easy. With the fraction button, we can go 31 pi over 15 minus pi. And it's going to give our outcome in terms of pi, which is freaking sweet. So that's going to be 16/15 pi, or you could say 16 pi over 15. Notice that that fraction is improper, so that cannot be less than pi over 2, which is 90. So we're going to have to minus pi again. And here we just hit minus pi again. And that gives us 1/15 pi, which would be pi over 15. Or you could say 1/15 pi. Now, if you want to compare that to pi over 2, you're going to have to get a common denominator, okay? Because remember that this angle has to be less than pi over 2, and the common denominator for 15 and 2 is 30. So 1/15 would be 2/30. A half in 30ths would be 15/30. Does that make sense? 15 over 30 reduces to a half. And it's clear to see now that 2/30 is definitely less than 15/30. So our reference angle for this angle would be pi over 15. And again, I'm going to prove that going to the coordinate system. If I go a full circle, that would be 2 pi. But remember, our angle is in 15ths, so that would be 30 pi over 15. Our original angle was 31 pi over 15. So if this is 30 pi over 15, remember that's 2 pi, 31 pi over 15 would be how much past this? Well, I think it's pretty clear to see that if this is 30, I just need to go one more 15th to get to 31/15. And so my reference angle has to be pi over 15, or 1/15 pi. I think I'm going to call that good. If you have any other questions or comments, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.